This video will cover Chapter 3, Section 1, Quadratic Functions. Now we've seen quadratics a couple of times already and we've graphed them earlier. So this will just be a little bit more detailed, and it's going to be more than just that basic parent function. Alright, so we know that it's quadratic first of all because of the x squared. That tells us it's quadratic. And if we know what a quadratic graph looks like, because we've been looking at the parent functions, we know the shape of it should be in the shape of a parabola. Alright, so we're going to be asked to find a couple of things. The axis, the domain, and the range. And then we're going to look at some intervals on which it's increasing and the intervals on which it's decreasing. Alright, the first thing we're asked to find is the axis. And so remember, I told you earlier, whenever you have a quadratic function or quadratic equation, that it makes a parabola, which could either look like this or like this. Alright, and we said that they are symmetrical. Alright, and they have this axis of symmetry where I could fold it down that axis and the points on either side would match up, and they had corresponding y values. Alright, so we said this is the axis, this is going to be the x, alright, the axis x, and then we're also going to be using the vertex, which is either the lowest point on the graph or the highest point on the graph. And by just looking at the function, we should know which way the parabola is going to face. If it's going to open up, then the leading coefficient a is we'll say it's greater than 0, and if it's facing down, then that leading coefficient a is something less than 0. So this just says my leading coefficient is positive, this my leading coefficient is negative. Alright, so when we look at our function x squared minus 6x plus 8, I can see that the leading coefficient is a positive 1. So my graph, when I graph it, should look like this. Alright, I know it should open up like that. Alright, so the first thing we're going to do is we're going to find the axis of symmetry, and also that's going to tell us the x value of our vertex. Alright, so what we're going to do first, alright, to find the axis or the x value of our vertex, we're going to use, I told you this earlier, negative b over 2a. Alright, for our problem, the a is 1 and the b is negative 6. Alright, so what we need is the opposite of b. So the opposite of negative 6 is 6. And then our a is 1, so we'll have 2 times 1. That'll give us 6 over 2, which simplifies to 3. So our axis should be where x is, so we can see, our axis should be at 3. And that's also going to tell us the x value of our vertex. Okay, it doesn't ask for the vertex in these questions, but when you graph it, you're going to need to know the vertex. Okay, so we're going to come down here and find the vertex, and the way we do that, remember, this is x. Alright, so what I'm going to do is I'm going to find y, or f of x. I'm going to fill in 3 everywhere there's an x. So in place of x, I put a 3 back in my original function. So 3 squared would be 9. 6 times 3 is 18, plus 8. Then if I add all of those together, 9 minus 18 is negative 9, and then plus an 8 would give us negative 1. Alright, so the vertex of our parabola should be at the point 3, negative 1, and this should be the lowest point on our vertex when we graph it. Alright, so we now have graphed it. We know where the axis is. It's always the x value of our vertex. And now we want to look at the domain. Okay, so let's go ahead and graph. Before we continue forward, let's go ahead and graph it. So we know that our vertex is at 3, -1. 1, 2, 3. And then 3, -1. Alright, there's my vertex. And then I need 2 additional points. The good thing, remember, about parabolas is they are symmetrical. Alright, so to find additional points from the vertex, if I go -1 and +1 on the x, so -1 would put me at 2 for my x, and +1 would put me at 4 for my x. Alright, I know the good thing about these 2 points are they have the same y value because the vertex is symmetrical. So really I only have to solve for one of them. So I'm going to say my y equals, and I'm going to fill it back into that original function. Alright, so 2 squared minus 6 times 2 plus 8 would be 4 minus 12 plus 8. And then 4 minus 12 is -8, plus 8 would give us 0. Alright, so I can say that the other points would be 2, 0, and 4, 0. Alright, so I'm going to come and graph those on my graph here. So I'm going to go 4, 0, and 2, 0. And you could pick additional points if you wanted to make go 2 to the left of the vertex, 2 to the right of the vertex. When you're picking your x values, fill them in. They should have matching y values. Alright, so then I'm going to draw my graph. Alright, notice it faces up, and I know that it should because my leading coefficient is positive. Alright, so the next thing we want to look at is the domain. Remember, the domain are all the x values. So when I look at my graph, I can see that the domain, the graph continues on forever in the right, the positive direction for x's, and the graph continues on forever in the left or negative direction for the x's. So I can say that the domain of my parabola goes from -infinity to +infinity. So any x value would work. Now remember, the range are the y values. So when I look at my graph, what's the lowest point on my graph on the up and down? The y. Alright, and I can usually base that off of my vertex. That's either going to be the highest point if it's on the hill, or it's going to be the lowest value if it's down here in the valley like ours. So we said our vertex was at the point 3, -1. 3, -1. So my range is going to start at -1 and move forward. Alright, so when we enter it, or when we write it out, alright, we're going to include -1 because it is a value. Alright, -1 to infinity. And make sure you put the brackets because we're including -1 as part of the range. Alright, the next thing we want to look at, the intervals for which the function is increasing, and we're looking at the domain. Alright, so we're looking at increasing x values, decreasing x values. Alright, and you can base that also off of the vertex. So the point, the vertex is where the graph shifts directions. Alright, so from here we're going, if we're following the x values down, 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 and we get here to the vertex that's at 3, and then it shifts and starts going up. Alright, so the place where the function is increasing is at 3. It starts at 3. Now this time we're going to use a parenthesis because the 3 is not the ending spot. It's just the spot where it shifts directions, changes directions. Alright, so those are our x values from 3 on up. Alright, and then where it's decreasing is going to be anything less than 3. So remember, you always write the smaller value first. So from -infinity to +3. Alright, and if you'll notice, all of this information can be found if you find the vertex of the parabola. Alright, the increasing and decreasing intervals are usually always going to look something similar to this. All right, the range is going to look something similar to this. It may change if the leading coefficient is negative. It'll just be reversed. All right, the domain of the parabola always looks like that. And then the axis is just the x value of the vertex. All right, so let's take a look at another one. All right, so this time we have negative 4x squared minus 40x minus 96. All right, so when I look at this, I see maybe that I could factor out a 4, but we're just going to go with this for the time being. All right, because my leading coefficient is negative, I know my parabola should be upside down, like this. And my vertex is going to be somewhere up here on top. All right, so to find my vertex, I'm going to say x equals the opposite of b over 2a. My b is negative 40, so that's going to be positive 40 over 2 times negative 4. Makes it 40 over negative 8, which puts our vertex, the x value, at negative 5. All right, so here's the negative 5. All right, so there's 4, negative 5. All right, so this should be our axis of symmetry, where x is negative 5. And so then I'm going to fill negative 5 back in. Negative 4 times negative 5 squared minus 40 times negative 5 minus 96. All right, and that'll give me negative 4 times 25 plus 40 times, that would give me 200 minus 96. That would be negative 100 plus 200 minus 96. Remember, this is how we're finding the y value of our vertex. So negative 100 plus 200 minus 96 gives us a value of 4. So we should be able to find our vertex at negative 5, 4. All right, so I'm going to go left 5, and then I'm going to go up 4. All right, and that should be my vertex. That should be the highest point on my graph. All right, and then what I'm going to do is go to the left from my vertex, 1. And then I'm going to go right, 1. All right, and these two y values should be the same because our parabola is symmetrical. So if I go the equidistance from the vertex, from my x-axis, my y values should be the same. All right, so I'm going to fill in negative 6 into my, or negative 4, doesn't matter which one, you can, either one. All right, so we're going to say negative 4 times negative 6 squared minus 40 times negative 6 minus 96 gives us negative 4 times 36 plus 240 minus 96, and that'll give us negative 144 plus 240 minus 96. All right, and that gives me a value of 0. All right, let's see. All right, so my 2 points should be at negative 6, 0, and 4, 0. All right, and that seems logical since my parabola should be pointing down, so when I connect my dots, all right, my parabola points down. All right, now what I can do is use that information to answer the other questions. All right, so our x-axis is going to be the x value of our vertex, all right, which we said our vertex is here. All right, negative 5. The domain, all right, is still, we're continuing in this direction, so we're continually widening, following all the x values, so it's going to be negative infinity to positive infinity. The range, all right, notice the highest value that we have